All right, guys, so today we're going to be working on our Calculus Notes 5.4 Part 2, and we're going to be doing use substitution with ease. Remember that we only use use substitution when we're doing integration. Also, we have a new rule here with integration, and it's kind of easy because the integral of e to the u du is just e to the u plus c. A lot of the times when we find this u value, it's going to be the value in the exponent of the e. However, sometimes we need u to be the value in the denominator, or it could even be a value under a radical. When we're doing the u substitution, the du value needs to be nearly equivalent to a factor of the expression. So on example 1, we're just going to try letting u equal the exponent. And the reason I have to do that is because I don't just have e to the u, so I have to make this u. So now du then is going to be 3 dx multiplied by a third. And so now my problem becomes a third of e to the u du. So we're going to have 1/3, the integral of e to the u is just e to the u plus c. And now I do need to replace the u, and it's 1/3 e to the 3x plus 1 plus c. And that's going to be our answer on that one. Okay, looking at example 2, again, I'm looking at this and I don't just have the integral of e to the u. So I'm going to have to let u equal the exponent. So du then is going to be negative 2x dx. And I'm trying to replace the 5x dx. So in order to get a 5, I have to get rid of the negative 2 and I have to multiply by a 5. So if I do this kind of replacement, then my negative 2's go away, and now I have 5x dx, and that's what I need to replace is the 5x dx. So right here is 5x dx. All of that's going to get replaced with negative 5/2 integral of e to the u du. And so now integrating this, I'm going to have, that's going to turn into negative 5/2 e to the u plus c. And now I just need to replace it. So it's going to be negative 5/2 e to the u plus c. Now recognize with this being a negative exponent that we could also take that to the denominator. So if you look in the back of the book or in the answers to our book homework, you might see it written like this or like that. Those would be equivalent. Whenever I have a base and the exponent's negative, I can make that a positive exponent by taking that factor to the denominator. All right, looking at number 3. Number 3, again, I can see that I don't have a u as my exponent, so I'm going to have to let u equal 1 over x. Well, another name for 1 over x is x to the negative 1. And so then du then is going to be negative 1 x to the negative 2 dx. When you first look at that, it doesn't look as though that's going to help us, but this problem can be thought of as the integral of e to the u, and then this can be thought of as, sorry, let's write this as 1 over x for now. And this can be written as x to the negative 2 dx. Because if I want to take it to the top, it's x to the negative 2. And that's exactly what we needed. We need this x to the negative 2 dx. We do have this extra negative that we have to contend with, so we're going to take that over there so that we have exactly x to the negative 2 dx. So all of this right here, that's going to be du with the negative 1 in front. So we have negative the integral of e to the u du. And that integral of e to the u is just e to the u. So our answer is going to be negative e to the u plus c. Oops, sorry, u is 1 over x, not that. Yeah, make sure you look in the right place for your u. Here's our u, not there, here. So that's going to be 1 over x right there. And that's going to be our answer. Okay, on example 4, again, on this one, I'm trying to think about, well, if I let u equal x, that's not going to be effective at all. because the derivative of x is just dx, and I would still have all of this to worry about. So on this problem, I have to go about it a completely different way. I'm going to have to let u equal the denominator, 1 plus e to the x. And that's because the derivative of 1 is 0. The derivative of e to the x is e to the x dx. Now, I'm going to change these values so that now they're going to be u's instead of x's. This is an x now, this is an x now, but now I'm going to make them u's. So plug in the x's. E to the 0 is 1, plus 1 is 2. Now this is a u value. Plug in 1. E to the first is e to the first, plus 1 is just 1 plus e. So now we've got e values here, and so that's going to be a lot easier because now I'm not going to have to go back to e's. I'm just going to stick with u's. So my problem now becomes du is e to the x dx. So all of that right there is du. 1 plus e to the x is in the denominator, so I have to put a 1 in the numerator as a placeholder. So I've got 1 over u. Well, the integral of 1 over u is natural log of u. So I'm going to have natural log of u. Because this is a definite integral, I don't need to go back to x's. So I'm going to have ln of 1 plus e minus ln of 2. And that's going to be my final answer on my definite integral. All right. On example 5, on this one, we're going to have to think ahead as to what we want u to equal. So to get the u value, we need the derivative of the u to be equal to the other part of the expression. So if I let u equal what's under that radical, then du then, that derivative is just e to the x dx. So right here is e to the x dx. That's going to get replaced with du. Right here is the u value, and we have to see what's happening to that. Well, if we're taking the cube root of it, it's going to be to the 1/3 power. And so now I'm going to want to add 1 to that. And after I add 1, I have to multiply by the reciprocal. And so that's what we're going to get for our answer, but we can't leave a u in the answer because we started with x's. So if we start with x's and now we have u's, we're going to have to replace those. So we're going to have 3/4, look back at what u was, and then we've got to the 4/3, and then plus c. And that's going to be our answer on that one. On the last problem here, we've got to look at the problem and see whether it's definite or indefinite. It's definite, which means that we are not going to have x's in our final answer. We're only going to have constants. And so I look at the exponent here. That's what we're going to let u equal. So u is going to be 1/2 x squared. So du then, the derivative is going to be 1/2 times 2 is 1x dx. Right here is the x dx that we need to get rid of. So that x dx then is going to get replaced with du. And we've got e, and then right here, this is the u that we talked about. And then these are going to have to change into u's, so we don't have to go back to u's. Right now, this is x equals 0 and x equals radical 3. But we're going to stick with u's from this point forward. So I'm going to plug in this x into here to make it a u. 0 squared is 0 times 1/2 is 0. Plug in radical 3. Radical 3 squared is 3. Half of 3 is 3/2. And so now we have a definite integral that we can go ahead and evaluate. So looking back here, the integral of e to the u is e to the u. So therefore, this integral then is just e to the u. We don't need plus c because it's definite. And we have 3/2 and 0. And now we're just going to substitute in for our u. So it's going to be e to the 3/2 minus e to the 0. E to the 0, any value to the 0 power is just going to be 1. So our answer is going to be e to the 3/2 minus 1. You could even write this as the square root of e cubed minus 1. Or you could write it as e radical